So now we're going to see the stack implementation using array. So for that, what I'll create a stack, let's say stack array example, not example, implementation dot java. All right, now I'll delete this one. I'll come over here and click over here. Okay, now what I have to do is we have to take the data members, we have to take the constructors, we have to initialize and stuff that's going to do, and I'm going to write each and everything and you will understand all. All right, let's create those data members. Let's say private, and I'm going to take integer max size. I'm going to take the max size variable, that this is going to be the maximum size of the stack. Okay, after this I'll write private int top. I'm going to take one top variable, that is going to be the index of the top element. Index of the top element. Okay, now I'll take one more array, because we're going to implement stack using array. So I'm going to take array over here. I'll write integer array and name of the array to be, let's say, stack array. Okay, so this array we have taken, this is array to store the element of the stack. Store the element of the stack. Okay, these are the data members we have defined. Now I'll write a constructor to initialize the stack. Constructor to initialize a stack. Okay, what I have to write for that? Public. What is the stack, what is our class name? That is stack array implementation, right? Stack array implementation, this is going to be the constructor, and inside this constructor I'll initialize the max size to be size. So one variable I'll be taking, that is the size. It will give the size. Okay, I'll take input as int size from it. This size is going to give to the max size, and what we're going to do is that stack array, I'll take one stack array, and in that I'll creating the dynamically. So I'll write int, I'll give allocation dynamically max array, max size. All right, so this is I'm going to pass into the stack array. All right, so this size, because this is the maximum size, and whatever the size can change, right? So that is that, like, to take care of that. So here what we're doing is we have given that. Now what I'll do is I initialize the top. So I initialize size also, max size, that is. I initialize stack array also. Now I initialize the top. Right, from the three data members you can see I have to initialize this top also. Okay, top is the what? Top is the, that's a variable that's going to keep track of the peak element, that is the top element, right? So I'll initialize with -1. So what does this mean? It means top -1 to indicate an empty stack. Top -1 indicates that stack is empty. Why? Because there is no index called -1 in an array, right? You already know that. Okay, now if I go ahead and we will implement all the functions that we did. Now we'll check if the stack is empty or not. How to check if the stack is empty? If you already got it, you can pause and try to write it, like check if it is empty. Check if stack is empty. What should I write? I'll write public boolean is empty function. I'll create, this is inbuilt function, anything name you can give over here. I'm writing is empty function because in the previous code we did is empty function, you remember. So here I'll return whenever it's empty, that time top is going to be equals to -1. It means no elements is there. So this is going to check if top is -1, it means the stack is empty. If top is the size of the array, that's the fullest it is entered, right? Okay, now if I want to check if the stack is full, what should I do? Check if stack is full. What I have to do? I'll call a function public boolean. I'll write a function, that is function name is going to be is full, let's say, and this function will check if the stack is full or not. So what I'll return is, I've returned that if top is equals to max size -1. Why -1? Because array index starts from 0, so that we have to write the -1. So if top is not only equals to max size -1, that time it will say that it means top variable at the top, right? We are trying to say the top is at the max. If this is max, right, max size -1, this will be max size -1, because max size is the size of the array, right? So that is going to be there. All right, so this will give the top value. Now let's suppose you want to insert element in the stack. So push element into the stack, or insert element into the stack. So there we use the push function. You remember that inbuilt function. Here we're going to create that push function, how actually internal working of that push function is. So I'll create void push, and in this we'll give the element that we want to push. So element. Okay, this element we want to push, let's say. So what is actually happening in the stack is, we'll check if this stack is full or not. If it is full, we cannot enter more, because that will overflow will happen. So the stack overflow.com is offset is there. So that is that name derived from here. If the stack is full, all right, and you are entering more element, that is not going to be entered, because this is a array, this is implementation by array. So it's going to be what? It's going to overflow, right? So we will check if the stack is full or not first. After that we'll enter. So I'll call isFull function. After calling isFull function, I'll write system.out. If it returns the value, then I'll write println, and here I'll say what? Stack is full, cannot insert more elements. This is valid. If the stack is not full, so in the else part I'll be writing, correct? In the else part, what I have to do is, let's say stack elements are not full. If say 14, 30 is not there and top is pointing to here, right? What I have to do is, I have to increment the top. I'll have to come this position first, this array of index 2, then I'll enter the value. So that's what I'm going to do here. All right, I'm going to increment the top first, so this will go to the next, and after that, what are the element we have taken, we will input in the stack array in the top index, and I will give the value element to that, and I'll print system.out.println, and in this I'm going to write post element is, I'll do the concatenation, and that's going to be the element. I do concatenation, I'll do on to the stack. Okay, so I'll give some space over here, and okay, now this is the push function. All that is the internal working of this push function. Here we were writing, right, this push function, the internal working is like that. All right, so this push function is done. Now suppose I want to implement the pop function also. So what I'll write is public. Okay, let's write something that, you know, like write the comment, that is pop the element, that is deleting the element, right? So here what we'll write is, you know, I'll write the function, I'll create the function public. Let's say I'll take type to be integer, because we're going to return that value whatever the popped element is. Okay, I did not take any kind of, you know, parameter here. So pop function I've created. Suppose I want to delete element from this stack, and if it is already whole empty, so if it is already empty, what to delete, right? So what we'll do is we'll check if the stack is empty or not. If is empty function we'll be calling, and we'll check if there is empty or not. If it is empty, system.out.println, if it is empty, this will be executed, and we'll say stack is empty, stack is empty, stack is empty, cannot delete more elements, right? This is what we're going to say, and what we're going to return -1, because we are doing it's of return type is what, integer, right? Else we have to delete it. Okay, how to delete it? So what I'm going to do is I'm going to store the top element in something like, you know, in the one variable. Suppose I will delete it 40, I'll be storing it in some variable and I'll be printing at the last. So what I'll do is I'll decrement the top, because top variable is going to point to here, this part, right? I will decrement the top from here. Okay, so what I'll do is I'll store whatever the value I have to delete. So I'll write popped element, and that's going to be, you know, that's going to be what, stack array of top element, that is the element I have to delete. So I have to come back to the position first, that I have to decrement the top minus. So I decrement the top, and I'll write system dot out dot println, and here I'm going to say popped element is what, I'll do concatenation and I'll do popped element from the stack. This is what it's going to print. Okay, now next what, I have to return the value also, return popped element, because this is the element we are deleting it. So this is the pop function. Okay, now what more function we saw? We saw the top value, right? Peek function, right? Get the top element from the stack, that also we can do. So let's say you know, public int peek function I create, I can give any name. I'm giving peek right now, because we have seen that this is the function actually inbuilt there, right? So I'll write if, we'll check the function is empty function. If it is empty, then no value is there. So what is the need of top? So what I'll write is empty function I'll be calling, and I'll be checking, and I'll go inside it and I'll print that system.out.println, and here I'm going to say stack is empty, so no top elements, so no top elements there in stack. Okay, again I'll come back here and I'll return -1 if some elements is there. So in the else part, I'm going to return that element, and that element is going to be the stack array top, because that is the element over there, right? So this is the peak function. Okay, now what is the size function? That you already know. So let's have a get the size of the stack. Size of the stack, I'm going to write, let's say, public integer type size function, and inside this size function I'm going to return top plus 1. That is going to be, because top, that is the size of the stack, is going to be there, means size of the stack means size of the array. All right, now I'll come out of it, and here we will write the main method. So what are you going to write? Public static void main, and in this string of array arguments. Okay, inside this I'll create the object for the stack. So what is the stack name? We'll create object for the stack, and class name is stack array implementation, and we will do what? We'll create the object for that. So stack array implementation, and let's say stack I create as the object, and I have to write new stack implementation. Let's say I give size, I have to give the size of the stack, right? So I give size as the 5 here. Okay, now let's suppose I want to enter the value. So I'll write what? Stack dot push function I'll be calling. Suppose I want to insert value. Suppose I want to insert 10 into it. So this will get 10 at the first position. Like I'll give stack dot push function again, and I want to enter, let's say, 20 now. So this will give the value as 20. If I write stack dot push, and I want to give, let's say, 30, so it's going to give 30 as a value. So these are the elements entered. Suppose I want to check top element here and size of the stack. Size of the stack we can see 3, and top element we can see that is 30, because first element is 10, 20 and 30, right? So if I print it, system.out.println, and here I am write top element is going to be what? I'll be calling that function stack dot peak function, because peak function we have created for the top element, if you remember. So that will be giving the top value. Now let's suppose I want to find the size. So system.out.println, and I want to see the size of the stack. So here I'll write size of the stack is, and I have to call that size function. So how I'll call stack we have created dot size function. So size function. Okay, I have to concatenate, this is going to be plus. Okay, now this is fine. Now let's say I want to delete those elements. Suppose these elements I've entered, and I want to delete those elements. So for deleting, stack.pop we use, that is going to delete the element. Again, suppose I want to delete it, stack dot pop is going to be there, right? So stack dot pop function. Okay, it means we are deleting 2 elements. If I hit Control S, let's say, and suppose I want to print this, right? That, and what I'll do is I'll copy these 2 lines also, and I'll paste it over here. So after deleting 2 elements, I'll be pasting over here. So this should give the peak as element as a 10, because 2 elements are deleted, that is 30 and 20 are deleted, right? So let's hit and Control S and try to run this code, and if it's justifying the answer or not, let's see. Okay, so pushed element 10 onto the stack, pushed element 20 onto the stack, pushed element 30 onto the stack. Okay, top element is giving to be 30, that is correct, and size of the stack is 3 till here. Now after this we did the pop operation, so popped element is 30 because that is the top element, so that's going to be deleted. After deleting that, top element is going to be 20, that is deleting, then top element is showing what, 10. All right, before this, here if you print the top element, that top element is going to be, what's going to be top element. If I check over here, the top element, you already know, one time we deleted, top element should show as 20 here, and size of the stack at the last is 1 because 2 times deletion we did. If I hit Ctrl S and I run it again, you can see the top element, it will give as the 20 here, and after that is going to be delete, 20 is going to be deleted, and that's going to give the result. Let's run it and I'll understand what I'm trying to say. Okay, let's run this code. So you can see top element is 20 and after that is coming. Okay, let's say we can delete more elements, that you already know, right? I'll click it over here. You know that we can delete more elements because one more element is there. So I'll write stack dot pop function. If I write it, it will delete one more element. I'll hit Ctrl S, and if I delete one more, so it will automatically be executed, right? Here if I can check the size of the stack at the last, it will show what that size is. No size is there, isn't it? If I hit run over here, so size of the stack at the last is 0 because we all deleted all. Let's say we want to delete more elements. Suppose we want to delete more elements. Stack is already empty. I'll hit Ctrl S, and if I run this, let's say what it says, because we have covered that case also, right? So it says stack is empty, cannot delete more elements, right? So if you enter more elements, push more elements here also, that will say stack is full. It cannot, because size we have given 5. Okay, let's say here I'm writing stack dot push, and I want to enter element more than 5 elements, right? Suppose I want to enter more than 5 elements. Let's say I'll write 40 here, and it will obviously take the input. I'll write stack dot push function, and here let's say 50 here. It will obviously 5 elements it will take, but till here if I hit Ctrl S and till here if I run, there will be no issue, right? Because 5 elements it can take. The stack can take 5 elements. So you can see all elements are there, and 50 is the top element because 50 is the last element we have entered, because it's a last in first out is the algorithm. If I again enter stack dot push, stack is already full, right? If I enter let's say 60 over here, if I enter 60 over, and I'll hit Ctrl S and I'll run this code, see what it is saying. If I run this code, you can see stack is full, cannot insert more elements. Top element is still showing to be 50. This is the use of all the functions we did. This is the implementation of stack using array, and after this we're going to see implementation of stack using linked list. Thank you. So we are going to implement the stack using linked list. So let's create one file, stack linked list implementation .java. All right, so here we're going to implement that stack, we're going to write that stack linked list implementation. What I'm going to do is I'm going to take this bit down, and we will create the node over here. So we know that we have to create the node that we did in the linked list, right? Same thing we're going to do here. So we're applying with singly linked list. So int data is going to be there, correct? And next pointer is going to be there, node next pointer. These are the data members we have defined. Now what I have to do is I have to create the constructor for that. So what I'll do is I'll take input as a data inside this, and here I'll write this dot data is going to be data, and this dot next is going to be null. Okay, now after coming out of this, I will create the stack. So I'll name the class to be stack, and inside the stack all the operations that is going to be there. All right, so let's take it up a bit. Okay, here we're going to declare all the things. So what I'll do is I'll create private node, and in that I'm going to take the top variable because this is the reference to the top of the stack. Reference to the top of the stack. Okay, after that I'll create a constructor and I'll initialize the top that reference with something. So I'll create a constructor to initialize an empty stack. Constructor to initialize a empty stack. Okay, so what I'm going to write is I'm going to write access modifier and the stack I'll be giving, and in that stack, because the class name is going to be stack, so we have to write the constructor name as a stack also. So I'll write this dot top equals to null. When I give null, it's going to initialize the empty stack. Okay, now after coming out of this, I'll check if the stack is empty. Same functions we could write check if stack is empty. Okay, how to check if the stack is empty? I'll write the access modifier public boolean is empty function will be creating, and here will be return if top is equals to null, it means the stack is empty, right? This is the meaning. Okay, now here we'll not write the stack full because in arrays we know it's a fixed size. There we used to write the full function, but here this is a linked list, so it has no size, definite size, right? We can change the size, so we'll not write that function. That is not applicable here. Okay, now here we'll do what? Push an element onto the stack. How to do it? I'll write public void, let's say, is the return type we're taking, and push function we are writing, and here we're going to insert the data. What we did, if you remember, in the push function there, if you remember here, what I actually did, here we check this full or not. Right now we don't have to check, and we incremented the top and we entered the element in the array and we printed it, right? Here we have to create the node first, isn't it? Because that's we do in the linked list. So let's say new node I'll create the new node dynamically, and I'll give node, and I will pass the value, whatever the value I want to give. So data I want to pass, so I'll give the data over there. And what I'll do is, new node what I have created, I have to increment the top also. So here we used to write top plus plus, right? Top plus plus, but we know we created the new node, it's in the first position, then I have to increment the top variable, right? So I'll write is new node is equals to top. This is what set the next pointer of the new node to the current top. Set the next pointer of the new node to the current top. Because the next pointer is going to be new node dot next, because new node dot next is going to be the top, that is going to be the value, right? Okay, now what I'll do is I'll write top equals to new node, and whatever the new node we're going to take, that I'm going to give the value over here. So update the top to point to the new node. This is what we're doing. This is update the top to point to the new node. This will update the top value, right? So what I'll do is I'll do the visualization also. You'll understand. I'll show you something that how it's going to be done. All right. Here we are updating the top, and here we are setting the new node next to the top, right? Current top. Okay. This is what push function is. Now, if I want to write the pop an element from the stack, how to pop it? So to pop the element from the stack, it has to check if it is empty or not. So I'll write, public integer type and pop function I'm going to write, and it's going to check if the stack is empty or not. If is empty function will be calling. If that gives a true value, I'll write system dot out dot println. Here I'll give, say that stack is empty, cannot pop element. Okay, and I'll return -1. Now if this is going to be if, okay, otherwise what I have to do is I'll write int popped element. I'll take one variable, let's say popped element I'm taking, and in this popped element what I'll do is I'll write top dot data. Top element I have to delete it, right? So it will get the data of the top node. Get the data of the top node. Okay, now what we will be doing is we're going to move the top. We are updating the top to the top next is going to be there, right? What I'll write is top equals to top dot next. What actually doing here? Move the top to the next node. Move the top to the next node, right? And what we'll do is I'll return the popped element. Return popped element. So this will give the value as it will return the whatever the element we have deleted. Now this is all about it. Now suppose you want to find the top element, what actually is there, right? So this will do the visualization, everything we're going to do right now. Try to see it. Okay, you already may have got that what we are doing it. So we're going to write for the peak function, I'm going to write finding the top element. So you already know that finding the top element was going to be there if the function is like, if the it's already empty, what I have to do, nothing, no top is there, right? So is empty function will be calling if it is already empty. So I'll write system dot out dot println, and here we're going to say stack is empty, cannot pick element, cannot pick element, and we will return -1. If it is not empty, so what I have to do, I have to return the top data, right? Return top dot data, whatever the top node is there, we're going to return the data of this. It is going to return the top value. Now let's suppose we want to write the display function also, that after printing all the stuff we want to, suppose I want to do display function. I want to display the elements of the stack. So I have to iterate and print it, right? You already know how to print it. We already did in the linked list, void display function, and we have to write the function display function. How going to write it? So if the stack is empty, no need to print it. So I'll write is empty function I'll be calling, and if the stack is empty, I'll be writing system, same thing I'm going to write. So for that, what I'll do is I'll copy this, I'll copy this and I'll be pasting over here. And stack is empty, I'll be writing can this, I'll remove. Nothing to print, nothing to print. Okay, and I will be return not -1, I'll be returning simply return back. Okay, if element is there, what I'll do, I'll take one node that is going to be the pointing to the top, right? So node, because we have to print from the top, right? So we're going to print that way. So what I'm going to take is, I'm going to take one current node current, and that will be pointing to where? Top. So this is what, start from the top node. This means what? Start from the top node. Okay, let's go ahead. Now here I'll write, one printing statement, system.out.println, and here I'll say that, whatever the stack is, and it's going to rest, it's going to print the stack, right? So I'll go over here, hit enter. I'll write a while loop from here until and unless the current become null, you run that loop. So what I'll do is current not equals to null, run that loop, and you have to print system.out.print. You have to print the data of the current dot data. I'll do the concatenation, I'll give some space over there. You have to print the data, and we will update the current also every time. Current equals to current dot next. So current is getting updated to current dot next. It means every time current is moving forward. And at the last, coming out of this while loop, here I'll give one enter statement so that it looks good. Or println, I'm just formatting the code. Okay, this is all done. Now what I have to do is I have to come to the main function. And like this stack linked list implementation function, and I here going to write the main method, public static void main, and in this main method I have to pass the string array args, and inside this I will create the stack. So what is the name of our class name? We have to access this class, right? So I have to create object for the stack. So I'll write stack over here. So name is going to be stack, stack, and the object name I'm going to write a small letter in stack. Okay, here I'm going to write new stack. The stack is been created. Now suppose I want to push the element, stack dot push I want to do, so the element is going to be entered. So let's say 10 I give the value, and similarly I'll copy this and paste it. Control C, go to the next line, paste it, next line, paste it, next line, paste it. So whatever amount of elements I can give, because there is no size limit, right? Because it's a linked list. So 2, 3, and let's say it's 40. And here let's say I want to display the stack, so I'll write what? Stack dot display function. So it will print the it will give the output as what? 40 20 40 30 20 10. It will give the result as that. Okay, now let's say I want to write one printing statement here, system.out.println, and here I want to see suppose I want to delete an element, and I want to see what is the element is deleted. So let's say popped element is, and here I'll concatenate it, and I'll just directly call over here. So I'll write a stack dot pop function, So it will be plus concatenation we are doing. So here will be pop function, right? So this will give the value. So here it will be deleted pop element will be 40 because that is the topmost element. Let's suppose I want to check the peak element, right? System dot out dot println. I can find the peak element here. So I'll write, peak element or the top element is, and I have to get out of it concatenated stack.peak function. Okay, so it will give the top element. If you see over here the peak element, you can find that also. All right, now here if I call this stack.display function again, all right, it will give as a value as what? Output would be 30 20 10. So you can see in the let me explain once again. So here in the push function, you can see pushes the element onto the stack, so it creates a new node with the given data and updates the top to the stack accordingly, right? So we are updating the top, like this is here we're setting the next pointer to the new node of the current top, and we are updating the top to the point to the next node. Okay, I'll hit Ctrl S and I'll try to run this code, and after that we'll see the visualization of this linked list implementation of the stack. Let's see what result we are getting. So stack is 40 20 30 20 10, popped element is 40 and peak element is 30. You can see because after deletion of 40 it's going to be done, but like 30 is there in the front, right? And stack is 30 20 10. Okay, you can implement the size function also here. Now I'll hit Ctrl S. Okay, now this is done. Now what I'll do is I'll show you guys that how the visualization can be done, like stack using linked list. So let's go to that and try to do it. Okay, so let's see how it is done. Let's say we want to enter 10 at the first element, right? So see what it is going on. All right, so I'll decrease the animation speed, okay, so that you understand better. All right, now 10 is entered and top is pointing to that position, and this is the next of the 10, right? Let's say I want to enter 20 over here. I hit enter. See, 20 came over there and it got connected to this, right? And top element is giving what? It means 20's next is connecting to 10. Now you can understand, if I give let's say 30 over here, so 30's next is going to connect to where? 20. 30's next is connecting to 20 at the top, like that is element, and top is getting updated to this. So you can understand here we are writing what when we are pushing it. So that 10's next, first we give 10 value and next we get 20. So 10's next, whatever the new node we created, new node we're going to create, that next is going to point to the top, right? So that is actually happening, right? This is, suppose I want to enter one more value. See, so 40's next is going to point to where? Top, and after that we'll update the top, isn't it? That the first thing we have to do. So what will happen is 40's next is going to connect to 30 and 30 is what? The top element, and we will update the top at the last. I'll hit enter. 40's next is connected to this, and previously top was this and now top is this. You can understand this is like that new node next is going to be point to top, and we are updating the top with the new node, but whatever we have taken. All right, that is actually it is happening. Okay, let's suppose we want to delete it. Suppose we want to delete one data, so that data is going to be deleted. So top dot next is going to be the top, right? We are moving the top to the next node. So let's understand this. So here let's suppose I want to pop the data, so this deleted, and you can see it's getting updated. Top is getting updated to the top dot next. You can understand by this code, right? In the pop, top dot next is giving to top, right? That is getting updated. If I delete pop, click pop again, so this dot next is going to be there, right? Pop, so top is going to be what? Top dot next. Again, next top is going to be this top, so top dot next is this one. If I delete it here, so it is going to point to there. So that is the exam. This is the visualization of that. All right, hope you have understood like what I tried to explain. All right, thank you guys.